In this lesson, we're going to learn about the Pythagorean theorem and how to determine the side lengths of right triangles. We will also be able to identify if three given side lengths do create a right triangle. So let's take a look at the parts of a right triangle. Here we have the right angle represented with this symbol. The two sides that create the right angle of the right triangle are called legs. The side opposite of the right angle is called the hypotenuse. The hypotenuse is the longest length of a right triangle. Pythagorean theorem simply states that if you take a leg and square it, and you take the other leg and square it, and you add those two sums, these two areas, it equals the area of the hypotenuse squared. A squared plus B squared equals C squared is the actual Pythagorean theorem, where A and B are your legs and C is the hypotenuse. So let's take a look at what we have here. We can see that the leg of this right triangle, the height here, A, is 3 units tall. When we square that, we get an area of 9. Then we have the other leg of this white triangle, and it is 1, 2, 3, 4 units long. And when we square that, we get 16. This area here is 16. And when we add these two areas, we get the area of the hypotenuse squared. So we get an area of 25. So that is what the theorem says. You take a leg and square it. You take another leg and square it, and you add those two squares together, and it will give you the area of C squared, the hypotenuse squared. So we have 9 plus 16 gives us 25. Now let's determine the area of the missing square, and then use that to find the side lengths of the right triangle. So here we have a leg and another leg. The two legs created the right angle. Our hypotenuse is this length here. So this is going to be side A, side B, and side C. We know that we have an area that's 36, and if we add this area of the other leg squared, we get the sum, and this gives us an area of 100. So we have A squared is 36, B squared is 64, and C squared is 100. Now we want to find the actual lengths of the triangle. So the way that we got 36 is we squared A times A. So to undo something squared, we take the square root. So when I take the square root of this area of the square, I'm going to get a length of 6. So A is 6 units tall. Then the way we got an area of 64 is we squared B. B times B gives us 64. To undo the squaring, we take the square root of the area, and this gives us 8. So side B measures 8 units long. And then we are going to take the square root of C squared to get just C, and C equals 10. So the side lengths of this right triangle is 6, 8, and 10. In this diagram, we have the area of B squared, and we have the area of C squared, and we don't know A squared. So we know that if we add A squared plus B squared, we will get C squared. So we are going to subtract these two areas to get the area of A squared. So we're going to subtract, and we're going to get 25. So this area is 25. So A squared is 25, B squared is 144, and C squared is 169. So again, A squared plus B squared equals C squared. Now, to find the sides of the actual right triangle, we take the square roots of the areas. So the square root of 25 is 5, the square root of 144 is 12, and the square root of 169 is 13. So A is 5 units, B is 12 units, and C is 13 units long. So area A squared is 64. We don't know the area of B squared. The area of C squared is 289. So we are going to subtract 64 from 289 to get B squared. And this gives us an area of 225. So these are the areas, and now we want to take the square roots of the area of the square to get the length of the right triangle. So the square root of 64 is 8. The square root of 225 is 15. And the square root of 289 is 17. Now let's just find the missing length using the Pythagorean theorem. So we have our two legs. We'll call 5A, and we'll call the 12 is our B value. So we have 5 and 12, and we want to know what is the hypotenuse. So we take our formula and we plug in A and we square it. Then we plug in B, and the formula says to square it, and we get C squared. Now remember, we're just looking for C. So we're going to go ahead and square, and we're solving for C. We want to know C. We're going to combine these. And now we want to take the square root of C squared to get C. So we take the square root, and C equals 13. This time we have a leg of 6, a leg of 8, and we're looking for the hypotenuse again. So let's plug it into our formula. A is 6, it says to square it. B is 8, we square it. And that is equal to C squared. So we're going to solve for C, the hypotenuse. 6 squared is 36. 8 squared is 64. We combine these. We undo the squaring by taking the square root of both sides, and C is 10. Our hypotenuse is 10 units long. This time we do have a leg A, we don't have B, and we have the hypotenuse. So let's plug this into our formula. 5 squared equals B, we don't know, we square it, and that is equal to C squared. Okay, let's square all of the terms we can, and we're solving for B. Well, we can't just take the square root of B yet, or B squared. We have to subtract this 25 from both sides. Now we can take the square root to undo squaring, and B is 12. So this leg is 12 units long. We don't know A, We do know B, and we know C, the hypotenuse. So we're going to have A squared plus 24 squared is equal to 26 squared. So we're going to square the 24 and get 576. And we're going to square 26 and we get 676. Whoops. We are solving for A, but before we take the square root, we need to subtract 576 from both sides, and we get A squared is equal to 100. We're going to take the square root to undo the squaring, and leg A is 10 units long. Again, we don't know the leg A. We know B is 20 and our hypotenuse C is 25. We have A squared plus B squared equals C squared. We're solving for A, so we need to subtract out the 400 first. Then we take the square root of both sides, and our A value is 15. So this leg is 15 units. A is 8 units, B is 12, and we're looking for the hypotenuse. Square your terms. Solve for C. Let's combine these. And it looks like we get 208. Now, this example, we're not going to have a perfect square. We do not have a perfect square number. So when we take the square root, we are going to use our calculator and round to the nearest tenth. So we're going to take the square root of 208. And we have to toggle the button, and I get about 14.4. So our hypotenuse is about 14.4 units. So you're not always going to have a nice, neat integer. Here we have A, leg A, and we have the hypotenuse, and we don't know the leg B. So we're going to plug that into our formula. We're going to square, and we're going to subtract out because we're solving for B, so we need to isolate B. And again, 204 is not a perfect squared number, so we're going to get about the value. I'm going to use my calculator and take the square root of 204 and then toggle that and get about 14.3 if we're rounding to the 10th. So our legs are almost the same length. We don't know A, our leg B is 11, and our hypotenuse is 18. We have A squared plus 11 squared equals 18 squared. Let's square our terms. Subtract out, whoopsie, forgot the 2 there, the exponent. Subtract out 121, and we're going to have 203. We're going to take the square root of both sides, and A is going to be not equal, but about. We get about 14.2. I'm going to just say 14.2. So A is about 14.2 units long. Okay, the converse of the Pythagorean theorem just simply states if you have 3 measurements, 3 lengths, and you apply the Pythagorean theorem and you get a true statement, then we have a right triangle. But if we get a false statement, the triangle is not a right triangle. So 8 and 10 would be the legs, A and B, because they are the shorter lengths. And then our hypotenuse would be C. So we're going to plug this in. We have 8 squared plus 10 squared equals 12 squared. We're going to square everything. We have 64 plus 100 equals 144. We combine these and get 164 equals 144. Well, since this is false, this does not make a right triangle. It can make a triangle, just not a right one. Now let's try 6, 8, and 10. This would be our A, our B, and our C. We have 6 squared plus 8 squared equals 10 squared. We're going to square all of our terms, and we're going to combine, and we get 100 equals 100. Well, since this is true, this is a right triangle. Now let's try these. Here we have A, B, and possibly C. We have 5 squared plus 7 squared equals 12 squared. 25 plus 49 equals 144. And then when we combine these, we get what? 74 equals 144. That is false. So this is not a right triangle. And that's using the converse of the Pythagorean theorem. Let's test this one. 15 squared plus 20 squared needs to equal 25 squared. 15 squared is 225, 20 squared is 400, and 25 squared is 625. We're going to combine these and we get 625 equals 625. This is true. So this is a right triangle. Here, 5 and 12 would be the legs if this does create a right triangle. We have 25 plus 144 equals 169. We're going to combine these and we get 169 equals 169. So yes, this is a right triangle. And then lastly, we have 7 squared plus 10 squared equals 14 squared. 49 plus 100 equals 196. 149 equals 196. No. So this is not a right triangle. And again, that's using the converse of the Pythagorean theorem. I hope this helps.